Hi, this is Dr. Pan recording from Tucson, Arizona. Hope life is treating you well, and thank you for watching this clip on graph or trig function here. We're asked to find the period and phase shift of this function. Obviously, this part is the easiest one. That's the height, or if you want to impress your friends, you can say it's the amplitude. Okay. This chunk over here is kind of tangled together. It's a messy, but it affects the period, which is how often, how long it takes for the curve to come back to itself, and what we call the phase shift. It's basically the curve gets moved left and right. So basically, amplitude is how high this curve gets to go up and down. Okay, phase period and shift is basically to see is the function got stretched out, or maybe the function got squished together, and is the function get shifted over even if it's stretched out. Okay, so those two things are a little messier, but nothing that we can't handle. So let's get started. What you need to recognize is this. I'm going to put this one right here right now, and we'll make sense out of it now later on. Trunk, then move. It sounds so weird now, but hopefully at the end of this clip, after 4 or 5 minutes, you'll see this what this little secret really is telling you, and for the rest of your life, trig functions will never ever stress you out. Okay, so let's see what we really mean by this. It's Friday, my tongue is tied here. All right, we're going to start with a regular pretty looking sine functions. There are 5 critical points on this function. What we need to do is find with this dislocated function where the critical 5 points goes. If you have those 5 points, you can pretty much duplicate, and they're called cardinal points for the trig functions. If you have those 5 points, then your function is pretty much well defined. Okay, let's put this is a regular sine function. Okay, this is the pretty one. Now we were given a little more nasty one, sine of 4 5 pi minus pi over 9. A lot of students make the mistake, hopefully you won't, make mistakes thinking this is the shift. No, not shift. The reason is that this coefficient in the front, think of it as you are in, let's say, a communist country, China, let's say. Okay, this thing is what you think you want to say, but you can't see it because you are in a different country. What you need to do is this. Okay. Get this constant out first. Then, this is x. Okay. You had a pi over 9 before, and since you pull the constant out, you need a, what's the word I'm looking for? You need to compensate for it. Let me rewrite it so it's a little more clear. 4/5 x minus pi over 9 times 5 over 4. The 5 over 4 is not a mystery number. Okay, now notice I pulled the constant out. So if you redistribute it, 4 over 5 x gets back what you started with. 4 over 5 times 5 over 4 cancels out. You do get the pi over 9 back. The reason we need to pull the constant out is because this is where we read the shift. Okay, so basically you must speak the same language before you can call this is the shift. Okay, now thus this is what I was saying before. Truncated before move, or before moving. This is the moving part. Where's the trunking part? This is the part that affects the function, whether it gets stretched out or gets squished together. Okay, that's why we see it's truncated before you move. So basically, pull the coefficient out, then look for the shifting. All right, now the next few minutes, let's take a quick look how we're going to graph this one. So let's put our function back in again, we had a y, oh, there's my big hand, y is equal to 8 sine, I'm going to leave in the truncated function, that's, let's start with the regular one, 9. We package, think of you moving out of your apartment or maybe your parents' house. You're going to truncate it first, and then this one becomes the shift. Okay, so pack your suitcase first before you move out. This is the moving out part, and this is the packing part. Okay. Now, earlier I said that we need to find out what the critical 5 points are for a graph. And I cheated a little bit. I went ahead, I found those 5 points for us. So basically what we need to do is take the gut of it. You're going to set it equal to 0. That's the equivalent of this point. You're going to find a new x. Okay. And then you're going to do same thing. And now this time you're going to set it equal to pi over 2. You're going to find another point. So on and so forth. So what I have here is a computer-generated graph. Okay. Now, you might be surprised to see what all those fancy x's are, 5 of them, like I said earlier. Then there's nothing surprising about them. Each one of them is corresponding to old x equal to 0. This one is equal to old x equal to pi over 2. So those are just the cardinal points I found before. X equal to 3 pi over 2, and x is equal to 2 pi. Okay. On the bottom chunk over here, this is if you have a nice unmodulated function. Those are the 5 points. Okay. On the top here, the not so nice numbers are the modulated function. That's the function we're trying to graph. Okay. If you're in doubt, solve the one of them. You'll see they're corresponding to each one of them. And here's our nice graph. As you can see, this graph gets shifted because the 0 point was here, and each one of the points corresponding to my cardinal points as I needed it to graph any function. All right. So overall, what you really need to remember is this: truncate before you move. Pack your suitcase before you move out. All right. Once again, from Tucson, Arizona, this is Dr. Pan. Oh, I do have a pretty picture here. This is where I live in Arizona, and it's beautiful this time of the year. Anyway, this is Dr. Pan recording from Tucson, Arizona, making math easy and fun, at least trying to. If the video has been helpful, I would appreciate a comment or a thumb up. Until next time, have a confident day.